If the efforts of the 10,000-plus people who developed and assembled the James Webb Space Telescope are any indication, the age of the independent scientist are well and truly over. Newton, Galileo, Kepler, and Copernicus all fundamentally altered humanity's understanding of our place in the universe, and did so on their own, but with the formalization and professionalization of the field in the Victorian era, these occurrences of an amateur astronomer using homebrew equipment all the more rare. In his new book, The Invisible World, Why There's More to Reality Than Meets the Eye, University of Cambridge public astronomer Matthew Bothwell tells the story of how we discovered an entire previously unseen universe beyond humanity's natural sight. In the excerpt below, Bothwell recounts the exploits of Grote Reber, one of the world's first, and for a while, only radio astronomers. One World Publishing. Excerpted with permission from The Invisible Universe by Matthew Bothwell, One World 2021. The only radio astronomer in the world. It's a little strange to look back at how the astronomical world reacted to Jansky's results. With hindsight, we can see that astronomy was about to be turned upside down by a revolution at least as big as the one started by Galileo's telescope. Detecting radio waves from space marks the first time in history that humanity glimpsed the vast invisible universe, hiding beyond the narrow window of the visible spectrum. It was a momentous occasion that was all but ignored in academic astronomy circles for one very simple reason: the world of radio engineering was just too far removed from the world of astronomy. When Jansky published his initial results, he attempted to bridge the divide, spending half the paper giving his readers a crash course in astronomy, explaining how to measure the location of things in the sky, and exactly why a signal repeating every 23 hours and 56 minutes meant something interesting. But, ultimately, the two disciplines suffered from a failure to communicate. The engineers spoke a language of vacuum tubes, amplifiers and antenna voltages, incomprehensible to the scientists more used to speaking of stars, galaxies and planets. As Princeton astronomer Melvin Skellett later put it, the astronomer said, "Gee, that's interesting, you mean there's radio stuff coming from the stars?" I said, "Well, that's what it looks like. Very interesting." And that's all they had to say about it. Anything from Bell Labs they had to believe, but they didn't see any use for it or any reason to investigate further. It was so far from the way they thought of astronomy that there was no real interest. After Jansky had moved on to other problems, there was only one person who became interested in listening to radio waves from space. For around a decade, from the mid-1930s until the mid-1940s, Grote Reber was the only radio astronomer in the world. Grote Reber's story is unique in all of 20th century science. He single-handedly developed an entire field of science, taking on the task of building equipment, conducting observations, and exploring the theory behind his discoveries. What makes him unique is that he did all of this as a complete amateur, working alone outside the scientific establishment. His job, designing electric equipment for radio broadcasts, had given him the skills to build his telescope. His fascination with the scientific literature brought him into contact with Jansky's discovery of cosmic static, and when it became clear that no one else in the world seemed to care very much, he took it upon himself to invent the field of radio astronomy. He built his telescope in his Chicago back garden using equipment and materials available to anyone. His telescope, nearly 10 meters across, was the talk of his neighborhood for good reason. It looks a bit like a cartoon doomsday device. His mother used it to dry her washing. He spent years scanning the sky with his homemade machine. He observed with his telescope all night, every night while still working his day job. Apparently he would snatch a few hours of sleep in the evening after work, and again at dawn after he was finished at the telescope. When he realized he didn't know enough physics and astronomy to understand the things he was seeing, he took courses at the local university. Over the years, his observations painted a beautiful picture of the sky as seen with radio eyes. He detected the sweep of our Milky Way, with bright spots at the galactic center, where Jansky had picked up his star static, and again towards the constellations Cygnus and Cassiopeia. By this time he had learned enough physics to make scientific contributions. 2. He knew that if the hiss from the Milky Way was caused by thermal emission, heat radiation from stars or hot gas, then it would be stronger at shorter wavelengths. Given that Reber was picking up much shorter wavelengths than Jansky, 60 centimeters, compared to Jansky's 15-meter waves, Reber should have been bombarded with invisible radio waves tens of thousands of times more powerful than anything Jansky saw. But he wasn't. Reber was confident enough in his equipment to conclude that whatever was making these radio waves, it had to be non-thermal, that is, it was something different from the standard hot things below radiation we discussed back in Chapter 2. He even proposed the correct solution, that hot interstellar electrons whizzing past an ion, a positively charged atom, will get slingshotted around like a Formula One car taking a tight corner. The cornering electron will emit a radio wave, and the combined effect of billions of these events is what Reber was detecting from his back garden. This only happens in clouds of hot gas. Reber was, it turns out picking up radio waves being emitted by clouds containing newborn stars scattered throughout our galaxy. He was quite literally listening to stars being born. It was a sound no human had ever heard before. To this day, radio observations are used to trace the formation of stars, from small clouds in our own Milky Way to the birth of galaxies in the most distant corners of the universe. In many ways, Reber's story seems like an anachronism. The golden age of independent scientists who could make groundbreaking discoveries working alone with homemade equipment was hundreds of years ago. With the passing of the Victorian era, science became a complex, expensive, and above all professional business growth. Reber is, as far as I know, the last of the amateur, outsider scientists, the last person who had no scientific training, built his own equipment in his garden, and through painstaking and meticulous work managed to change the scientific world. All products recommended by Engadget are selected by our editorial team independent of our parent company. Some of our stories include affiliate links. If you buy something through one of these links, we may earn an affiliate commission.